Hello my dear viewers and listeners, I hope you are doing great and by the grace of Almighty you are having good health also. So in this video you're going to learn about electric circuit, and there are some symbols I have drawn in my board and I hope you know it, and those students are studying current electricity. You know that already I have explained some sort of basic of Ohm's law and also some basic point of electric circuit and electric current. So here in this video you're going to learn what is the name of this symbol and how to use it. So before going to explain, this is mandatory to know the basic of circuit. The circuit means is a complete pathway. That means from some point you'll start and then again some sort of traveling will end at the same point. So this is circuit. So in case of electric circuit, we can say that this is a complete pathway of the flow of electron, or you can say that complete pathway of current. So simply we can say that electric circuit is a complete pathway of current. So we know that current means is the flow of electron. So from some points it will start and then it will end up in the same point. So in this circuit there is something that is used actually in physics. So when we will study about current, electricity, we need to know that these are the basic symbols we need to learn. So what is this? I hope you know this is a longer line and this is a smaller one. So this represents the cell. So the cell means where the potential differences will go on, and that is why the circuit and the flow of electron will start. So this one is the positive side or positive terminal and this one is negative. So we tell it this is actually the cell. This is cell. So when there are several cells joined together at the positive side and similarly the negative side, then we'll say this is battery. This is battery. And now you see this symbol is going to represent a switch, but this is a one-way switch. You see that this one is two-way switch because there is two terminal, so it's gonna open here once again, and then if you just change the direction it will touch here. So it is two-way switch here, and this one is one-way switch. So switch means that from outside we can actually control the flow of electron, we can actually control the circuit. So through switch we control the circuit. This is one-way switch, and this is two-way switch. Now you see this one. So probably you know that this is actually the fixed resistors. Suppose because the line we draw, imagine that this is a wire, so it can move, so it allows as a conductor to the flow of electrons. But this one looks like, it's a hindrance, and this is resistors. So in this case we'll say this is fixed resistors. So this will fixed resistors, okay, and this is actually the variable resistors, or you can say it's real state. So real state means the variable resistance. I hope you have already watched my tutorial. I have explained about resistance and the types of resistance, and I also draw the figures of specific resistance and the variable resistance. So it represents this figure. When we'll draw it, it's like a fixed resistance, and then when you just give this narrow oblique line up to it, then it will be the symbol of variable resistors. So this is variable resistors or real state, and this is fixed resistors. Now you see here there is a sign. It means that a changing. So change the direction of electron flow, and that is why I call it AC source. So this is AC source. That means we call it alternating current source. So simply this is AC source, and this symbol represents fuse. So this is fuse because you see that in between a rectangular space, there is a very tiny wire which is actually made up of tin and lead, and these lines represents, this is made up of a very thin wire which is actually it can tolerate up to a minimum level of resistance, and that is why when more resistance will blow up here, then it will be melted, and then the intermediate lines will be broken up. So the next part, or the next machine that is actually connected here, it will be safe, and these will destroy. And that is why it saves the electric machines and some other things from being destroyed. So it destroyed itself because it's fused and it can tolerate up to a certain level of resistance. So this is fuse. Now you see these three symbol. Here is written G, that stands for galvanometer. This is A, stands for ammeter, and this is V, stands for voltmeter. So simply galvanometer is being used to identify if there is an instantaneous current flow in the circuit, and then ammeter is used to determine or to measure the current into the circuit. So it will give us a data on the ampere. So based on ampere, you know that the unit of electric current is ampere, and this is voltmeter, so that will be the unit of voltage or potential differences. So galvanometer, ammeter and voltmeter, these are the machines that we use to determine some fixed values, like galvanometer to the instantaneous electricity, this is current, and this is a voltage or the potential differences. So simply we can say this is galvanometer, this is galvanometer, and ammeter, and it is voltmeter. Now you see this one, this symbol represents, that is, a wire is connected with earth. So we can say this is earth connector or earth connecting wire. So these lines represent, suppose this is the line, and this one would be the bigger one comparatively, and then the smaller one will represent that this is actually earth connector. That line or the part of the circuit is connected to the earth. So this is actually the earth connector. Earth connector. And now you see, I mean, this one is actually, you see this two wire is just cross each other. So we can say this is a connecting wire. So this is connecting wire. Or we can say simply, no, this is actually not connecting wire, it would be, suppose, crossed wire actually. Crossed wire is because this is a crossed wire, and this one should be the connecting wire because it represents two different things. You see that there is a big dot where it actually starts with another one. So as this is the wire and this one starts from here, so we can represent this is connected wire. So we can say this is connected wire. And this one, you see that symbol is actually, this is the wire, and it crosses like this. It means that in one-dimensional aspect it looks like this. So when there is this line represents a current, and if something like that, then it means there is no physical adding here and no physical touch in between these two lines. So we can say this is not connected wire. So we can say that we're not connected. We're not connected. Now you see these two figures. This one and this one actually symbols of, or also we can say something like that. This one, this three actually represents bulb. Bulb. You know what is bulb? And these parallel lines represents electric capacitor. So it would be capacitor. You know that capacitor, and definitely it requires another individual classes to explain what is electric capacitor, because there are some rules and there are some interesting thing here to discuss it, and definitely I'll definitely upload different videos on electric capacitor. And now this one, it looks like coil. So simply we can say this is coil. So these are the things and these are the symbols we need to know what is the meaning of it and how to use it, what is their function primarily. So this is cell, so that is one type of a generator and one type of electric generator, small version. So it will produce the electric flow of current, and that will definitely the first part of a circuit. This is a battery. So this is the alternating current source. So it represents some wave, that means it changes the direction. Crossed wire, connected wire, and wires are not connected. And this one is actually two-way switch, you know, that I explained here. So this means that we can actually control the circuit from outside. This is one way, two-way. Rheostat, fixed resistors, fuse. It just save our electric machines. Fuses, it's just a safety measure. Bulb, capacitor, coil, and these are the machines: galvanometer, ammeter, and voltmeter. Now you see, if we draw a circuit, how it looks like. Simply, we can say that the circuit is a complete pathway of current. Now you see that you draw the cell, and then there is a bulb added, and suppose there is a resistance and switch. So we add something here. So now you see the positive and negative terminal of the cell. So this is the positive side and this is the negative side. So from the positive side to the negative side, the electric current will flow, and through this direction we can actually show that how it will flow. But now you see very simply that these one-way switch are not connected. So right now this circuit is not functional. So it will be functional when they will add it like this. So when switch is on, that means they are connected. When switch is off, that means they will be like this. So there is no physical connections in between these. So simply from the word switch, we know that switch is the outside controller. So this is switch, and the flow of electron will be from the positive side to negative side. Okay? So now you see that one thing I should actually mention here, the earth connector. The earth connector. If you add here, this is, or I can say, suppose, okay, make it bigger, something like that. Okay, this is a bigger part, and this is a resistor, and again there is a resistor, fixed resistor, and again there is a resistor, and there is connections of earth connector. Now if you see the point of A, B, C and D, very important. I'm just giving a very primary idea that this is the positive side and this one is the negative side. So the current will flow through this direction from A to B to C to D. But the voltage of 4 different points are different. As because this D is connected with the earth connector, so the voltage of this point is 0. But the voltage of A and B is definitely this. The volt is equal to this, the cellular potential differences. If I say the voltage is 6 volt, if this is the 6 volt and this is 2 ohm is connected each other, 2 ohm, then there is something that we need to consider very carefully. What's going on here? So 2 ohms, 3 resistors is added here in this circuit, and 6 volts is added. So if you want to know that what is the current is flowing here, then we need to apply definitely the Ohm's law. We know that Ohm's law is I is actually V divided by R. We know it, that electric current is actually the potential differences divided by the resistance. Now, what is the resistance of this entire circuit? To understand that, we need to know, that is, single one, we need to find out the equivalent resistance of the circuit. What is equivalent resistance? Before going to explain, we need to know what are the types of circuit. And this is simply two types, series and parallel. What is series and parallel connections? Now you see that in this figure, three resistors, which is fixed resistors, are added one after one, and each and every single resistors have two different point of voltage. So these resistors, which is R1, has the voltage of between VA and VB. But this one, which is R2, represents the voltage between V and C. But this R3, that resistance presents C to D. So each and every time that resistance, they're having a different voltage. So if this resistance are connected in such a way, this is called series connection. But if it happens like this, that the positive side and negative side, that is a resistance, again that is a resistance, again that is a resistance. Now you see that every time, suppose this is the earth connector, all the terminal part of the resistance is connected with the positive side, and the other part is directly connected with the negative side. That means you see that in this resistance, the positive side, the negative side and the positive side is connected with each other alternatively. So positive, negative, positive, negative, positive and negative. So they are connected one after one, and this is series connection. And this is actually the parallel connection, is because all the terminal part is connected with one single part of the electric source. So this is positive and this is negative. So simply we can say the types of electric circuit is two. Number one, this is parallel, and this is series. So we can say this is series circuit and parallel circuit. I'm just giving you an idea because I need to explain it more with another part, that series and parallel circuit, and what is equivalent resistance and how we'll find the equations in case of finding the equivalent resistance in series circuit and parallel circuit. Think about the equivalent resistance. There is connected three resistance. If I change this all resistance into a single resistance, just transfer it, the positive side and negative side. This is the one, and this one is the earth connector, positive and negative. Now you see that here, same previously the voltage is 6 volt, and this is the single resistance that is used instead of using these three resistance. Then the voltage was not changed. So instead of using three resistance, if we use a single resistance in any circuit where the voltage will not change and also the current will not change, then this resistance is called the equivalent resistance. As we are using it in series resistance or series circuit, then it will use as RS, and if we use this one, then it will be RP, because RP represents the resistance or the equivalent resistance in parallel connection, and this one the equivalent resistance in series connection. So series connections or the series circuit, it means where the resistances or some other particles, like we usually use the resistance is connected one after one, and the differences of the voltage is depending on the points, two different points, but here not same. So this is parallel connection and this is series connection. So when we use a single resistance instead of a lot of resistance, in case of parallel, then we say this is equivalent resistance in parallel connection. So we will use Rp in case of parallel and we will use Rs in case of series connection. So my target was to give you a basic idea, though it's actually not finished. I mean, there are a lot of things I need to explain, and the next video would be based on specific series and parallel connection, how we can find the equations of series and parallel connections, because there would be that Rs, if this is R1, R2 and R3, the equivalent resistance would be 2 plus 2 plus 2, that is 6 ohm. So the equivalent resistance of this circuit will be 6 ohm when we will find Rs. But in this case, we need to find that 1 by Rp is actually equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot dot till the number of resistance was used in the circuit. So how we'll get it, and how these equations will be derived, so that will be the explanations process in the next video. So I hope in this video I can make you understand that the symbols that will be used to draw a circuit, and what is the basic of series and parallel circuit. So I hope you can draw it, and do not forget this one. And I want those who are watching right now, please write with your own hand and try to draw this one so that you can memorize things, and you know that physics is a lovely subject. So, and of course electricity is another thing that is much lovable. So I'm coming up with the next video with series and parallel connections and equivalent